Another minute, are we ready? Okay, get me started. How do you take the derivative of a to the x, Mr. Bart?
You take the natural log each side.
Okay, sounds good. That allows you to bring that exponent down, take the derivative implicitly. What is the derivative implicitly, Sarah? Michaela? Oh, just take the derivative then. How's that sound? Implicitly means just x is y is not solved for, that's all. And the right side? Is a is constant, yeah? So what is the derivative of natural log of ax? What would the derivative of 2x be? 2, right? So when you take the derivative of that, the x just kind of goes away, and the constant is natural log of a. So remember, that's not a function, it's a constant, so just no product rule, just straight up take the derivative. So dy dx is y log of a, which is a to the x natural log of a. Now remember that in a second when we go to take the antiderivative. Excuse me. Somebody get me started on the next one. Jack, what would I do on the next one? Wonderful. A to the y equals just x, did you say? What did you say on the right side?
Yeah, just x.
Just x, okay, cool. And then, Ethan?
Y ln of a equals ln of a.
Okay, so take the natural log of both sides, which allows you to bring down the variable, or the exponent rather. Now I imagine that you took the derivative there, yeah? Would you just, by way of notes for the next problem, would you just pause and go off to the side and say, y equals log of x over log of a? That, compared to the original statement, that is called the change of base formula. If you didn't like log base a, you could change it to natural log, which for a lot of calculus reasons we would want to do, by rewriting it as a natural log of x over natural log of whatever the base is. Okay? That said, you could take the derivative here or there. Either way, though, y prime, or dy dx is 1 over x natural log of it. Does that look familiar? Yes?
Okay, so could you skip a step in the middle of that? And not do the exponentiate?
Skip step
So I went
from 1 to
y equals log base a of x to y equals
natural log of x over natural log of a. The change of base formula is, yes, especially if you remember it, and then you'll be in really good shape for the next part. All right, cool. So set 72 was derivatives of exponential and derivative of log base a. And we also did absolute value derivatives, which that's a whole different ball of wax. Today, then, we're doing the opposite, inverse, or the antiderivatives of exponential and log. One of them makes total sense. One of them is kind of a little different approach. All right? So here we go. What if you wanted to take the derivative of 2 to the x? Not the derivative, excuse me, the antiderivative. That is the derivative, so it seems like it's kind of like this, but it looks like it's missing something. When you take the derivative of exponential, you're supposed to just get that same thing back, a to the x, but you're also supposed to pick up a natural log of a. This derivative doesn't have a natural log of a, or natural log of 2. So then, what do you reckon we should do? Missing natural log of 2 from the derivative. Well, what do you think is a workaround that? Can I just bring in a natural log of 2? Actually, let's pause here. Just a second here. I'm not sure we're 100% with it. Before I go back to this, let's do a couple quick ones. Y equals 3 to the x. What's the derivative? geez, for Pete's sake, you have the derivative rule right there. Come on. 3 to the x, natural log of 3. If y equals 4 to the x, then y prime equals 4 to the x, natural log of 4. This is supposed to be a derivative of 2 to the x, but it doesn't have that natural log of 2. So I repeat, how can I get that natural log of 2 in there that I want to be in there? Yeah, I could multiply and balance with, what's the opposite of multiplying? Dividing. So I could multiply and divide by natural log of 2, which is obviously mathematically sound because it's a big fat 1. Now the 1 over natural log of 2 in the denominator, I'm going to pull that out front because I don't really need it, and I can do that because it's a constant. The natural log of 2 I'm going to leave in because that's part of the derivative rule. Now then, this, as we can see, is the derivative of what? 2 to the x. So when I undo the derivative, it must have been just 2 to the x to begin with. Now this, then, on one level, makes a lot of sense. When we take a derivative power rule-wise, we multiply by that exponent. When we take an antiderivative, we divide by the exponent, right? Well, the same goes here. When we take a derivative, we multiply by natural log. When we take an antiderivative, we divide by natural log. So it's all, to me, making sense. What then is the antiderivative of 5 to the x? Without all the work. 1 over natural log of 5 times 2 to the x. Okay? What's the antiderivative of 1/2 to the x? 1 over natural log of 1/2 times 1/2 to the x plus c, and so on. Okay? You follow? All right. Now let's go to the next idea. How do you take... Yes, hit me.
What if it was 1?
1 to... Good question. 1 to the x.
Because then it would be
Yeah. True that. Good question. This, then, obviously is undefined, and so it cannot happen. So what's to be done? Guess it's just undefined. You are correct. I never even considered that. Log of 1 is 0, and that's an undefined denominator of 0. Yeah.
Isn't it? No, it's
Okay. Let's see. What is the? Let me think more about that. What's the derivative of that?
0. Well, no, it's undefined because it's equal to that line.
Yeah, exactly. I mean, if you think of 1 to the x, it has no rate of change. Basically, it's always 1 no matter what the power. And so this is 0. So it would make sense then that there is nothing that makes that derivative, so it has no antiderivative. That's kind of fun. Interesting. Okay, log base A of x. This is hard to integrate, so the first thing you use is change of base. Remember that log base A of x is equivalent to natural log of x over natural log of A. So the first thing we're going to do is rewrite log base A of x as natural log of x over natural log of A. And then the natural log of A in the denominator is a constant, and so let's bring it out front. Okay. Now this is one of those gotcha problems. What's the antiderivative of natural log? Is it 1 over x? What is it? Yes, okay. So remember, this is by ultraviolet voodoo, integration by parts. Although it doesn't look like it because it doesn't feel like a product of two things, it is, because dx is a thing. So, what do you make your u? Remember, u, the best choices for u go by lipid, and log is the best choice for u. So u is, that means dv is whatever's left, which all that's left is dx. If u is log of x, then du is 1 over x dx. And therefore, dv is dx means v is x. So by integration by parts, 1 over natural log a times brackets, because we're about to get a sum or a difference in there. X natural log of x, or sorry, ultraviolet is uv, or x natural log of x. So I was getting ahead of myself. Minus voodoo, v du, is x times 1 over x dx. 1 over natural log of x natural log of x is fine, and the antiderivative of 1 is x plus c. Write yourself a note, please. If you remember, this, you do not have to show it every time. Need to show all the work every time. So, for example, if you had log base 7 of x, I would be okay if you went straight to the answer, which is 1 over natural log of 7 times x natural log of x minus x. Okay? Let's go with a little bit of applications. As we have learned a million times over, that integrals have lots of applications. So let's use this within a context of a problem or two. Let's go back and, sorry, I don't know why I separated these two pieces of notes. So what's the antiderivative of a dx? Don't even look at your notes. Over natural log of a times a dx. What's the antiderivative of log base a? Over natural log of a, bracket, times the quantity, x natural log of x minus x. Okay. All right. So let's talk about this bad boy, x times the antiderivative of 1/2 to the x. You can see that we have an exponential, but we also have a stray x. What do you think here? U sub, ultraviolet voodoo? What do you want to do here? Ultraviolet voodoo. One is not the derivative of the other, so let's use ultraviolet voodoo. U and dv. Again, that lipid idea. Log, there's no log. Inverse trig, there's no inverse trig. P stands for polynomial. Is there a polynomial? Yes, x is a polynomial. Let u equal x. Therefore, dv is 1/2 to the x dx. If u is x, then du is dx, easy enough. And then v is the antiderivative of 1/2 to the x. What's the antiderivative of 1/2 to the x? That's what we just learned. 1 over natural log of 1/2 times 1/2 to the x. Okie dokie. You could probably clean that up, but we'll leave it. UV then, ultraviolet, x over natural log of 1/2 times 1/2 to the x is UV minus voodoo V 1 over natural log of 1/2 1/2 to the x du is dx. All right. As ugly as it is, I guess I'm just going to leave that first product alone. What about the new antiderivative? Talk to me about what you might do. bring the constant out front, and then let's do at the same time the antiderivative of 1/2 to the x. So altogether, what are we going to have out front of this? What's the constant out front? 1 over natural log of 1/2 to the second, because we're going to have two of them, either all squared or just the denominator squared, whichever you prefer. We had one, then we're going to pick up another one. When we anti-differentiate 1/2 to the x again, times 1/2 to the x. Is it wrong if you don't have parentheses around the 1/2? Yes, it is. 1/2 to the x implies 1 to the x, not 2 to the x. And so will I take off without the parentheses? 100% yes, I will, because it's dead wrong. Okay. There's no dx there, sorry. That should be a plus c. Okay. Cool. How about this next bad boy? What do you see there in terms of strategy? U sub. Okay, well, you want to let u equal x squared. Therefore, du is 2x dx. We have x dx, so I'm going to move the 2 and call it du over 2 equals x dx. So I can make my substitutions 1/2 7 to the u du. When I have a definite integral with u sub, I must change the limits. So what does 0 become? 0. What does 1 become? But we really did look. Yeah, they look the same, but we really did change them. What is the antiderivative of 7 to the u? Talk to me. People, say it out loud. Weaver, talk to me. What's the antiderivative of 7 to the u?
Is 1 over L and U.
Yes, that's true. U or 7? It's up the base, yeah? 7. Log of 7, okay. Times?
7 to the U.
Perfect. All right. From 0 to 1. So 1 over 2 natural log of 7. I could envision also seeing maybe a 1 over natural log of 49 if they used rules to clean that up. Either way is fine though. And 7 to the 1 minus 7 to the 0 is 6. So maybe 3 over natural log of 7 is a nice answer. Oui. Okay, try the next one. I want to see how you're doing with volumes. Try it on your own. No calculator. The whole goal is to get practice on integration. There might be a little exponent algebra you might have to do before you integrate. Oops. Okay, before we move too far, check your integral. Do you agree with something like from 0 to 3, the integral of pi 2 to the x all squared dx? Yes? No? Okay. All right then. That is pretty wacky to integrate. We just learned how to do 2 to the x, and now it's squared, and it's not really u sub e, so what's to be done? Well, think algebra. How can you simplify 2 to the x to the second? Multiply, okay, power rule, we know that this is the same as that, yeah? Now I'd like you to undo what you just did, but differently. Yeah, this 2 to the x to the second is the same as 4 to the x. Now that, the reason you do that is because it's a heck of a lot easier to integrate than 2 to the x to the second. The idea is that you use the product rule by multiplying the exponents, then you undid that, but this time putting the squared in first, and then actually did 2 squared. All right, now we're rolling. That makes it like the exponential antiderivative. How do you take the antiderivative of a to the x? 1 over natural log of 4 times 4 to the x. There's a pi in there, don't lose it in the shuffle. Okay, so I have something like pi over natural log of 4 times 4 to the x from 3 to 0. So pi over natural log of 4, what's 4 cubed minus 4 to the 0? 63. So, something like 63 pi over natural log of 4. I remind you, don't need the units on there, but if you want to put units on there, they'd be cubic units. Cool? Okay. Try this one on your own. This one I really am going to let you do on your own. Not jump in and interrupt you. Teachers always say ln going up to my class. Ln of 3. I mean, when you say that, you say ln of 3. Do your teachers say that? I know I don't say that. There's no way in hell I would ever say that. Do your teachers say that? Because we're going to have a little talk at math department meeting, because that's BS, man. What is that? That's nonsense. Okay? Say it. I don't say, hey, SA, how are you? I say, Sarah, how you doing? Okay, don't give me that abbreviation nonsense. If it's around the y-axis, what will the variable of integration be, x or y? It should be y. So what's your R? Ten to the y. Perfect. Okay, and it is squared. Yep. My bad. Sorry. 10 to the y. Is the minus 1 in with the y or outside the fact? Y equals log x plus 1. 10 to the y equals x plus 1. So you're right, outside. Oh my goodness, is that going to make it not so doable by, well, let's see. I refuse to give in to the calculator yet. We'll see. I might change my mind in a minute, but we'll see. So just 1, so this is 10 to the y squared minus 2 times 10 to the y plus 1. I still say calculator is unnecessary. Pi, the integral from 0 to 1 of, what's the way to rewrite that? 100 to the y dy minus 2 times the integral of, this should be 2 the y dy plus 1 dy. Okay? What is all from 0 to 1? 0 to 1. What is the antiderivative of 100 to the y? Hundred to the y. 1 over natural log of 100. 100 to the y from 0 to 1. Minus 2 times, what's the antiderivative of 10 to the y? 1 over natural log of 10 times 10 to the y from 0 to 1 plus y from 0 to 1. We should have braces, but that's okay. So here we go. What's 100 to the y from 1 to 0? 100 to the y from 1 to 0 is 100 to the first minus 100 to the 0. Which is 99 over natural log of 100. Minus 2 over natural log of 10. What is 10 to the y from 1 to 0? 10 to the y from 1 to 0. 10 to the 1 minus 10 to the 0. 9 plus 1. And I think at that point, these really are like terms. We could make this log of 10 squared, bring down the 2, and combine like terms. What are you feeling? No? Yeah? Let's call it good. After that yawn, I'll say, let's call it done. All right. Then antiderivative of inverse trig. We've done this a little bit already. Is it going okay? Do you know how to, could you, on a homework quiz or something like that, take the antiderivative of that? Okay. All right. I will just focus on the new then. Let's start here. Now, this is inverse trig, but it's not quite 0 or something squared plus something squared like normal. Which would be arctic. Do you agree? So, how can we take that and make it something like square plus square? You complete the square. So, let's see how rusty you are at Algebra 1 skills. Okay? The idea on completing the square is it's not factorable in the perfect square with the 7 there. So you say, well, I'll push the 7 off to the side and put my own number there. What would go there to make a perfect square? What's the rule? Divide by 2 and square. So negative 4 divided by 2 is 2. Squared is 4. Now, obviously, you know at this point that you can't just go changing math without balancing. You can balance math two ways. Either change both sides of an equation, if you have an equation, or do and undo. Okay, now, I don't have both sides of an equation, so I can't also add 4 to the other side. There is no other side. I can, however, undo adding 4 with subtracting 4. I think you'll agree that there was no net change there. If I combine my terms back, I would be right back to where I started. So I have not changed the problem other than the looks, but the value is still the same. The reason I do that then is so I can write this as the square of x squared minus 2 plus 3. Now we're rolling. This is arctangent-ish. Remember, 1 over u, oops, what the heck? 1 over u squared plus a squared is a perfect antiderivative of arctangent of, oh, this needs to be 1, doesn't it? Sorry. Is arctangent of u. So, we have a little bit of arctangent work. The problem is that that is not, oops, that is not 1. How do I make it 1? Minus 2? What? Oh, I get it. Ah, that's a good one. No. Okay. Instead, you factor out a 1/3. I wish I would have reviewed now because I'm not so sure everyone's totally with me. If I factor out a 1/3, that's definitely 1, but now that's going to change this to x minus 2 squared over 3. You really need it to be all one big square. So would you write it as all one big square? X minus 2 over what all squared? Root 3. Okay. Wow, that's pretty strong. Okay, so the antiderivative is 1/3 arctangent of u, and u is x minus 2 over root 3. All plus. All right. That's completing the square. Would you like to give it a try on your own? All right then, let's practice together now. Let's go here. This one is not quite a perfect square because it has this terrible negative, yes?
Yes.
So I could call this something like negative x squared plus 2x. Wait. So far, so good. What pattern, by the way, are we shooting for? Arctangent or arcsine? Arcsine, and that's normally something like that, yeah? Okay, well then, let's complete the square. 1 over square root of negative of x squared plus 2x, and let's leave a space. What goes there? 1, yeah. Now, when I put a 1 there, did I really just add a 1 to that? No, by virtue of the negative out front, I really just put in a negative 1. So to balance, I need out here a 1. If I write this trying to put this into an arcsine pattern, how would you write this as a nice, clean, arcsine kind of pattern? Let's write that first, because that usually comes first, but then 1 minus, yeah, what's the square of what? X plus 1. Okay, boom, now it fits the pattern. You could let u equal x plus 1, in which case the antiderivative is arcsine of u, and instead of u, it's arcsine of x plus 1. Plus c. Okay, now you'll be happy to know that they don't really require a lot of this completing the square on the AP test, but it is definitely done at the college level, so I don't want you to be at a disadvantage. I want you to succeed. All right, What? Oh. Never mind. Okay, questions on, oops, now you're ready to try. Try this one on your own. Yay! I made a mistake here. Nobody said anything. What did I do wrong here? I forgot the dx that goes with my du. Shoot. Here, if u is x minus 2 over root 3, then what's du? Take the derivative. 1 over root 3 dx, so dx is actually root 3 du. This should have a root 3 du, a root 3 arctangent of x minus 2 over root 3. Going too fast. Make sure when you go to u sub that you find the du that goes with it. Okay, sorry. Tangent. How's it going? Did you get something like root 2 over 2 arctangent of x plus 3 over root 2?
Yes.
Let's see. Okay. All right. Questions on set 72. By the way, did you get packets? Did I hand out packets? Or little packets? If you have your, if you still have your old packet with answers through sets, what is it, Levi? Through set 70, then you can bring those back into your old packet and take the new packet, which will cover this. Right? All right. Questions on set 72. Did you say 7? Okay, 7. 14. Okay. 7 and 14. Boom. 46. Ha ha. All right. That's a good one. I like it. 7, let's see. Is 7 in place?
Yeah.
Okay, so it looks like okay. Okay, sorry, 72. All right. Time equals 0, there are 10 people in the store. Time equals A at, I'll let A equal amount of people. 10 people leave at a rate of E equals 0.12 squared plus 1 people per minute. Leave at a rate of 4 plus 4 cosine T people per minute. Give an expression involving integral for the people in the store at any time T. Wouldn't you agree that the people in the store, the amount of people in the store at any time T would equal start plus add minus leave, or enter minus leave. So the starting amount is 10. The number added is the rate at which they're added, E of T, times a small time interval, adding all those results from 0 to at any point T. Now, if it needs to be at any point T, then I'm using T up there, which means I can't use it down here. I'm going to need a dummy variable, so I'll call it X. Minus leave would be the same idea, L of X dx. You could definitely put those together into one integral if you were so inclined and call it E minus L. Either one of those is fine, you do not need both. Okay? B is the number of people in the store increasing or decreasing at time 4. There's two ways to look at this. From a fancy calc kind of way, you want to know, is the amount increasing or decreasing? And by the book, that means is A prime positive or negative? Well, A prime would be the derivative. Derivative of 10 is goners. Here, it's the derivative of the antiderivative, which is just the function. So you could say that the rate of change in the amount is just enter minus leave. Now that makes a whole lot of sense, because those are the rates at which people enter and leave. So together, they would be the overall rate of change. So A prime at 4 is E at 4 minus L at 4, which is something like 0.4 plus 1 minus 4 plus 4 cosine 4. I have no idea what that is. Whatever that is, we're going to look at our sign. Does somebody have a number for that? Positive? Do you see that that's a problem? You can't read your own writing, you goofball? Negative? I got some negatives, some positives. Golly. 0.6 minus 4 minus 4 cosine 4. I got negative 0.785. I guess that's something. I'm in radians. Oh, 1.4. Why did I say I don't? You're right. Mine's going to be wrong because I used 0.6, not 1.4. Point zero.
No, that's not.
Positive 0.0145.
No.
What do you mean no?
It should be not 0.4 is what it should be.
4 squared.
1.4 minus. Why is there a square?
0 squared. It should be.
4 should be
Oh, gotcha. That's why. Gotcha. So, 0.16, so 1.16 minus 4 cosine 4.
0.1 times 16.
That's what he did.
Oh.
He added the 1.
Okay. Wow, this is really rough for such a straightforward calculation. I'm looking at negative 0.2254. Okay then. It is, which is less than 0, so the amount is decreasing. You cannot just say give me the answer and say amount is decreasing. You have to say why it's decreasing, and it's because that rate change is moving. All right. Lastly, the max number of people in the store. The absolute max, is that an endpoint or a critical number? The endpoints are most definitely times 0 and 6. The critical numbers are where the rate of change in the amount, which is E minus L equals 0, which would also imply, I suppose, where does E equal L? Where do the rates negate each other or come out the same? That is at time equal, anybody have those intersection points? Guess not. No, I'm impairment. Okay. These are things that you should be able to routinely do if you want to do well in the AP exam. This should not be, I need your help, Mr. Rickman. This should be, I got this, no problem. Zero to 6. I see. Maybe 2 intersections. Oh boy. 3 intersections. Yes? Okay.
Isn't it gonna be one of those things where it's just
Oh, 0 to 6 though. Shoot, I didn't check it. I'm sorry, go ahead.
wait, no, never mind.
You could probably reduce the number by a few if you ruled out positives to negatives and vice versa. I have 1, 2, just 2. Yay. Intersect, boom, boom, 2, 2.2446. Guess that's all we get through. Should get through a lot more if we participate. Oh yeah, let's do today. Absolutely do today. 100% today. We will not be procrastinating anymore. I will grade based on completion. If you need help with 14, I'll be here after school. I can just tell you, you sub it. Let U equal x plus 1 for number 14 if you have a question. Hi. Oh, perfect. Thanks, bud.
Thank you.
Thank you. Have a great day.